If you guys still remember, are you guys ready or not sekarang ni? Dah ready?
Ready, sir.
Okay.
Yes, sir.
So last week
Ready,
we
sir.
learn, tak ada last week Yesterday we learn about 7.1, right? So 7.1 we learn about two formula, which is force and gravitation field strength. Dah try buat tutorial?
Dah, sir.
Okay ke tak? Boleh buat ke tak?
Sir.
So if you guys still remember, if you guys still remember, kamu ada F equals to G, M besar, M kecil, R square. And then you have F equals to G, ni A lah. A equals to G, M besar over R square. Okay, and if you guys still remember, yang M besar tu melambangkan mass yang besar lah, which is basically the one that is pulling ataupun the source of the gravity ataupun planet yang besar lah. Biasanya macam tu lah kita punya perumpamaan. Okay, that one is for 7.1. So you still have a few more, which is 7.2 and 7.3. For 7.2 is a simple things. You have gravitation potential, okay, potential. You have a formula of U equals to negative G M besar M kecil over R. Yang ni tak ada square. And the difference is over here you have a negative. And then kalau kamu ingat lah, dulu kalau kita belajar dekat chapter 5, gravitation potential ni U kan equals to mgh. Okay, this one kalau dekat surface of the earth. So basically here we want to see what will happen as it goes further away. Kalau R tu bertambah ke berkurang ke, I mean much further away lah, jauh daripada bumi. And then ataupun any planets lah. The last part we learn about satellite motion. Okay, satellite motion ni, satellite ke, rocket ke, planet ke, everything is what we call satellite. As long as dia ada rotation motion, we call that one as a satellite motion. So we can divide into two parts for the last subtopic ni, which is about escape velocity and orbital motion. I just write orbital. Kalau orbital, you need to know about V and T. Okay. Kalau escape velocity, you only have two formula, which is about V escape. Okay. We go into detail soon, but for now, I want to focus on 7.2. Okay, by definition, what is gravitation potential? Siapa boleh bacakan? Apa definition dia?
Work done by gravitational force to move a body mass of to move a body of mass from infinity to that point or.
Okay, good, very good. So, kamu boleh tengoklah kamu punya lecture notes tu, dia memang ada definition tu. And then actually kalau kamu tengok into details, sebenarnya dia melambangkan saya asyik lost connection. Anyway, kalau saya punya iPad terputus juga, saya tak pakai wifi kan. Sekejap, saya check. Okay, katakan saya punya iPad terputus, kamu WhatsApp saya punya, kamu Telegram saya, saya tak perasan. Apa tadi definition? Yang penting sekali, dia melambangkan pergerakan, work done required to move an object daripada infinity to a certain position. So it depends on position. Okay. So if I want to represent in terms of a graph, dia punya derivation, kamu boleh tengok dekat kamu punya nota, dia adalah integration You don't need to know, you don't need to derive pun. So saya tak tunjuk lah, kamu boleh tengok sendiri. So let's say if I want to represent in terms of U against R, this is the distance M, U is in joule. You guys ada bersama saya tak ni?
Ada sir.
Ada sir.
Ada. Merisaukan senyap. So katakanlah kamu ada bumi. Let's say this is our earth. Oops. Ayu. Okay, dah tak boleh gerak. It's okay. So let's say this is our earth. As it goes further away, the gravitational potential, the magnitude will decrease. Okay, so it will goes in this direction lah. So this one you can say that since the formula of U is equals to negative G, M besar, M kecil over R, you have the negative values, so that means it comes from down here. Okay, and then as it goes further increase, R ini besar, so towards the infinity, this number becomes small. So that's why approaching 0, like that. Okay, and then the unit here would be in joule, and then it's a scalar quantity. So scalar means it doesn't have any directions lah. So the negative to actually indicates energy in or out. Okay, by definition, it is actually work done ataupun work required to move a point mass daripada infinity. So let's say I have a point mass over here. I put this one as M0, point mass. Okay, let's say here R is equals to infinity and it brings closer to the certain position. Okay, the work done to do this motion ataupun untuk gerakkan benda ni is what we call the potential energy. Kenapa dia negatif? Okay, kalau kamu belajar dekat chapter 5 sebelum ni, work, kalau negative work maksudnya adalah apa? Work done by system. In this case, our system is these two objects lah. So according to Newton, as long as you have two mass 1, mass 2, you will have attractive force. Okay, so attractive force mean force yang menarik lah. So by itself, by logic, benda ni akan bergerak sendiri ataupun sistem ni yang buat kerja. So that's why the potential energy is negative. Okay, that's why you have negative U. Obviously you have the derivation lah, kamu boleh tengok lah dia punya derive daripada work done ni, macam mana kamu dapat U. But that's the idea. So memang ada negative like this, kamu biarkan je nilai dia negative. Okay, and let's say if you want to calculate on the surface of the earth over here, then it will be mgh. Itu adalah ringkasan daripada ini. When you substitute all the mass and the R, then we assume it is equals to mgh. Itu pun ada derivation dia. Again, you don't really need to know lah. So saya akan padam dekat sini sebab dia bukannya dekat bawah syllabus ni. Saya just nak tunjukkan. So nama dia sama, dia memang benda sama pun actually. So far ada soalan?
Tak ada sir.
Tak ada. Okay, that one is about the definition. But in terms of calculation, they're pretty much straightforward. Memang direct. You just have to use this formula. Okay, katakan at most, if I'm not mistaken, sekarang ni dia tak sebut ada berapa banyak maximum object dia boleh letak. But as far as I know, the maximum object they can use is 3. So let's say if I have 3 mass, 1, 2, 3, okay. This is example 1. I have M1, M2, and M3. Okay, so you have 3 mass in a closed system ataupun dia dah tak ada objek lain, ada 3 benda ni je. So you will expect every pair of these akan ada interaction. So katakan saya tutup dengan tangan yang empat ni. So you expect to have a potential between these two. Okay. How to calculate those potentials? Basically, this one is equal to again U for 2 and 3. And then over here we have U for 1 and 2. And then U for 1 and 3. Okay. The distance center to center is what we call the R. Okay. So if they want to calculate individual pairs punya potential energy, it will be U, contoh 1, 2 will be equals to negative, jangan lupa, G, mass of 1, mass of 2, the distance of R1 and R2. Berapa dia punya distance center to center. Kalau U23 equals to negative G M2 M3 R23, and if U13 negative G M1 M3 over R13. Okay, this one kalau individual dia nak U yang spesifik lah. But for total, so you can calculate U total in the system is basically U12 plus U23 plus U13. Okay, katakanlah kamu kira one by one, each one of these. You will get, let's say, negative 10. Sini negative 12. Sini negative 11 contohnya. So, basically you just add up all this number. So you get 33, negative 33. So negative tu buat apa? Biar je. Jangan usik. So just leave it as it is. Senang sangat. Kalau dikasih 10 sekalipun, buat je lah 10. Tapi tak adalah. Syllabus kan saya rasa 3 je maksimum. Kalau 2 memang senang lah. I mean 2 objects. Something like that. Yeah. Okay, any question? You guys clear on this?
Yes, sir.
Okay, so if you guys okay with that, maybe we can try to look at one of the tutorial questions. If I'm not mistaken, it will be question number 9 code. Yes, question number 9. Okay, try to look at the question number 9. Okay, so the mass of the moon is this much. The distance from the earth to the center of the moon is that much. Okay, find the gravitational potential energy stored in the earth-moon system. So ini ada dua objek je, and dia suruh straight away calculate dia punya U. Okay, cuba kira dulu. Can you guys see the question? Boleh nampak tak?
Boleh, sir.
Boleh Okay, cuba kira. I'll give you 2 minutes. Dia dapat tak? Okay, so this kind of question, first thing first, you have to draw lah. Walaupun dia nampak simple, maybe it's best if you can draw a little bit of something. Just gonna draw it. This is our Earth, and that one is our Moon. Okay, and the distance from the Earth center to the Moon center is given, so that should be much easier. So R is equals to 3.8 times 10 to the power of 8. Okay, how do you get the mass and all? Maybe you can get from the constant yang kat depan tu. They did give you dekat depan sebelum soalan objektif. Oops. Okay, so mass of Earth is given ME. Dapat berapa ni? Dah kira belum?
Dah, sir.
Dapat apa?
Dah, sir.
Okay, good. How much you get?
Negative 7.79 times 10 power of 28.
Okay, kita cuba tengok ya. Yang lain dapat sama?
Dapat, sir.
Okay. Okay, we try to see whether that one is okay or not. Okay, U is equals to G negative G M besar M kecil over R. The difference between those two lah. The distance, sorry. So it will be negative 6.67 times 10 negative 11. Mass of Earth is 6 times 10 to the power of 24. Mass of the Moon is 7.4 times 10 to the power of 23. And then over the distance 3.8 times 10 to the power of 8. You guys do exactly the same with me ke? Ada yang lain ke saya salah ke?
So, power 23 to
22 Okay. Alright, thank you. Yang lain sama? Now if you press your calculator,
Yes, sir.
dapat here 7.79 times 10 negative, 10 times to the power of 28. It will be negative, betul Unit dia apa? What's the
Joule.
unit? Joule. Okay,
Betul,
good.
sir.
Alright. Direction? Ada ke tak direction? Tak ada direction sebab dia adalah zero. Dia adalah scalar. Okay. Any question on this? Okay, senyap tu saya assume tak adalah. Now 7.3. It's about satellite motion. Okay, satellite ni tak adalah terhad kepada satelit MESAT ke apa ke. Dia any object yang ada orbit yang bergerak mengelilingi something, circular motion. That one is what we consider as satellite. Rocket pun kita consider sebagai satellite juga. Anyway, kita ada terbahagi kepada two parts. Okay, one is V escape. Another one is about the orbital motion, which is satellite motion itself lah. Satu tu maksudnya dia keliling, satu tu lagi adalah dia cuba untuk keluar daripada gravity pull. Okay, in terms of drawing, kalau saya nak lukis saya fikir nak lukis dulu ke nak tu formula. Okay, maybe saya boleh lukis dulu. So kalau V escape maksudnya, so you have your Earth. Oops. Okay, and then you have your rockets. Basically, you want your rocket to be launched into the space. Nak lancarkan roket ke angkasa. So by right, if this one goes into space, the direction will be something similar to this lah. Kalau kita punya direction ataupun velocity, kalau kita punya velocity tak cukup tinggi, what will happen is that dia akan pergi keluar and then dia jatuh balik. Okay, so you will see something like this. This is the Earth, katakan dia lancar kat sini kan. Dia akan gerak ke sini. Kalau dia tak cukup kuat, tak cukup laju, dia akan jatuh balik. Macam tu. Berbayangkan tak? Can you guys imagine how it works? Guys?
Macam mana saya cuba ulang balik.
Ulang balik. Saya katakan kamu ada
Ulang, sir.
Dia katakan this is the surface of the Earth kan. So ni bumi. Dan kamu ada roket. Macam tu. So roket ni kamu lancarkan. So obviously dia akan start to fly. And then kalau dia cukup velocity, which is more than velocity escape tu, dia akan terus keluar. Tapi kalau dia tak cukup, dia akan jatuh balik. Sebab apa? Dia ditarik balik oleh gravitational pull. Boleh bayangkan tak? Okay,
Boleh sir.
So
Boleh, sir.
that's the idea lah. V escape is about that. Kalau orbital motion, so secara ringkasnya kalau daripada gambar 2D, maybe saya boleh lukis something like this lah. Kalau orbital period, kamu ada, let's say, a sun. Okay, anggaplah ini sun. Macam telur goreng. And then you have the period ataupun kita ada bumi. Okay. Itu peta apa tu? Katakan dia keliling matahari. So this is what we call the orbital motion. Dia keliling matahari. So dia sebagai satellite untuk matahari lah, bumi ni lah. So when we try to consider this motion, there are two important quantity. Number one is the velocity. Number two is the period. Okay, tadi kita ada V escape. Now we have V dengan period T. V here, the formula would be square root of GM over R. T here is equals to 2 pi square root of R cube over GM. So formula ni is given. You don't have to memorize or anything. You just have to use lah. And then the M here, if you look carefully, this one is the capital M tu. So capital M means M yang besar. So kalau saya nak kira velocity of the Earth dengan velocity period of the Earth, saya pakai M apa ni? Earth ke Sun?
Sun.
Sun. Sebab dia yang punca graviti. Dia lah punca, Sun ni lah punca bumi ni bergerak berputar. Kalau dia tak ada, obviously dia akan pergi melilau lah. So, hope you guys can understand. The V there actually represent the linear velocity at certain position. So V dekat sini is what we call the V here. So this is what you calculate lah. V yang kira tu V linear. Tapi dia obviously dia bergerak orbital lah. And then V ni unit dia obviously ms minus 1. How about the period? Kalau kita ada bumi mengelilingi matahari, satu complete period berapa lama tempoh dia? Berapa lama bumi mengelilingi matahari untuk satu putaran lengkap?
365 hari.
1 tahun 365
Tahun.
days. Okay, good. So you can multiply 365 days with numbers of hours, which is 24, and then multiply with 3600 so that you can get numbers of second untuk one complete cycle. Ini adalah some of the important facts yang dia memang takkan sebut dalam soalan exam, tapi sometimes kamu kena gunakan. So T untuk Earth around Sun is 365 days. Kamu tak perlu fikir tahun lompat ke apa, pakai je 365 days. Okay, any questions so far about orbital motion? Any?
Tak ada, sir.
Okay, in fact these two actually unrelated. Macam tak ada kena-mengena pun. Satu ni direction macam ni, satu lagi benda ni. So the only relation that you might have is that dua-dua ni melibatkan gravity lah. Cuma satu tu direction dia keluar ke situ. Yang kalau V ni direction dia tu tangential to the orbit. Sentiasa macam tu. Okay, back to the V escape. We have a formula. Oops. V equals to 2 square root of 2gm over r equals to square root of 2gr. Okay. The difference between these two, okay, sometimes student confuse lah. V yang ni adalah velocity, yang ni adalah V escape. Dia memang sebut V tu untuk escape gravitational pull. So dalam soalan pun dia akan sebut V escape lah. So immediately you know that one is V escape. Kalau dia tak sebut, most likely it is this one. Tapi kena baca jugalah soalan dia betul-betul. Kalau roket tu di launch, V escape jugalah. And then you will notice you have two formula, this one and this one. So you can use this part for Earth. So contohnya roket ni nak escape gravity of Earth. So you can use this simplified formula. Dia dah ringkaskan. Dia masukkan mass of Earth, radius of Earth, and then you get this formula. Okay, kalau dia kata nak cari daripada moon, then you have to use mass of the moon, radius of the moon, you have to use this formula. Ini ringkasan, ringkasan formula. So ni capital M. Again, kalau capital maksudnya mass ni mass satellite ke mass bumi?
Bumi.
Yes, okay, good. Okay, very good. So student akan confuse kat situ lah. Pertama, V ni V apa? Ni V apa? Yang kedua is about mass. Okay. Okay, now dua-dua ni soalan senang. Kalau kamu memang faham the difference between these two, you shouldn't have any problem to solve. Sepatutnya tak ada masalah untuk selesaikan. Okay, this formula actually derived daripada conservation of energy. Dulu lah Dr. pernah tanya, I think about many years ago, dia pernah tanya satu soalan yang susah sedikit je, which is basically you have to apply the concept of conservation of energy. So you know that this one is actually they use EI equals to E final. Okay, ini ada dalam nota kamu lah, you can see if you want, and you can try to look how they derive. So initially on the Earth, you will have the kinetic energy as the initial energy plus with the initial potential. When you are on the surface of the Earth, you still have the potential, and then equivalent to K final plus U final. Okay, and this one will be negative lah, tapi saya tak tambah juga situ sebab dia tambah jumlah tenaga. Okay, now when you try to escape the gravitational pull, basically you want to escape any effects on the gravity. So this one you want it to be 0. Okay, so if this one is 0, then you have half mu square plus ui equals to half mv square. Okay, katakanlah dia nak kata for minimum. Okay, contohnya dia kata what is the minimum velocity required so that the rocket will be able to launch ataupun will be able to escape the gravitational pull ataupun be escape lah. So if you want to find the minimum, we assume that this one is 0 as well. Okay, sebab apa? Contoh saya letak example numbers. Kamu ada potential energy, kinetic energy, katakan 10. And then you have the gravitational potential energy, also 10. Ataupun kurang lah. Yang ni 8, itu negative 10. Obviously dekat sini, you get a negative. So it doesn't make sense. So that's why, kalau ini negative, maksudnya roket tu tak launch. Dia naik, dia turun balik. Okay, itu satu maksud lah. Kalau dia lebih, ataupun dia betul-betul sama, exactly the same, so this one becomes 0 kan? That's why this one becomes 0. So this is the minimum required. So this is the V escape. Kita tak ada U lah, launch punya velocity ataupun V escape. Kalau dia lebih, let's say this one is 12, so you have 2 joule over here. Okay, so it depends on the questions lah. Most of the time, dia akan tanya yang ni. Yang mana? Minimum V ataupun V escape, where they assume this one is 0, so you can straight away use this formula. Formula ni derive daripada sini, buat ni atas ni. Kalau dia lebih macam ni, inilah satu soalan dulu dia pernah tanya yang quite hard untuk student lah, tapi tak ada masalah pun. Dia kata cari V launch, cari velocity kat sini bila dia ada kinetic energy. Itu je. So tak adalah masalah pun, buat persamaan je. Cuma dia tak ada straightforward masuk formula. I just point it out so that you guys understand V escape tu apa. Then you can differentiate lah between V escape dengan V biasa ni. Ada soalan tak?
Sir,
Yes.
maksudnya nilai energy final tu dia sentiasa jadi 0 lah kalau basically punya soalan lah, yang kebiasaannya soalan.
Sebab biasanya soalan dia tanya V escape ataupun V minimum. We assume berapa banyak energy required untuk cukup-cukup je dia keluar. Dia lepas dia buat bodoh. So tak gerak tak apa. Sebab vacuum kan. So dia keluar, energy semua dah habis guna untuk overcome the potential, and then dia just stay like that. Kalau dia ada lebih, maksudnya dia akan terus bergerak lah. Walaupun dia 2 joule, dia akan keep on moving slowly gerak away. Understand?
Oh, okay, faham sir.
Tapi most of the time, yes, soalan dia macam ni je. Dia tak disebut pun pasal energy. So don't worry too much. Yang bawah ni more to derivation and more to the concept. Saya tunjuk juga sebab katakanlah dia tanya, at least kamu ada idea. But most of the time, straightforward, dia kata find the escape velocity when you want to launch a rocket from the earth. Maksud dia lah nilai ni. Tak masalah. Okay, now let's try to look at few example. Maybe we can try to look at the next question. I think question 11 lah. Tadi kita buat soalan mana ya? Lupa. Tadi kita buat 9 ke 10?
9.
9 sir.
Tadi 9.
9. Tadi 9. Okay, maybe kita boleh buat 10 terus. Kita buat 10 dulu. Lepas tu kita buat 11 and so on. Tampak siap kat sini so that lepas ni kita copy. Okay, question number 10. Determine the gravitational potential energy of a 1000 kilogram communication satellite orbiting the Earth at an altitude of 4000 kilometer from the Earth's surface. Okay, soalan dia nak apa?
Gravitational potential energy.
Okay, good. So nak pakai formula apa? Dia nak U ke, V ke,
U.
T ke? U.
Dia nak
Okay,
U.
good. Alright, U is equals to negative G M besar, M kecil over R12 lah. Okay, now maybe kita boleh draw sedikit lah so that kita tak tersalah. Okay, no harm drawing especially this chapter, sebab masalah student biasanya bila like determine dia punya R tu. Okay, now dia kata mass of the satellite M is equals to 1000 kilogram. Okay, the altitude is 40k. So 40k tu daripada mana? From the Earth's surface, right? So maksudnya daripada surface lah. Agree or not? Something like this.
Agree,
Yes,
sir.
sir.
Okay, this is your 40k. Okay, remember when you try to substitute, you have to use SI unit dalam meter. Okay, so if I want to solve, then U become negative 6.67 times 10 negative 11. Mass besar tu biasa kita pakai mass Earth. Baca betul-betul kadang-kadang dia kata moon yang terus main sebab je pula. So 6 times 10 to the power of 24. Mass of the satellite 1000. And then you should have the distance here, which is, okay, for 40k, so the R is basically center to center kan. So it should be from here to here, betul tak?
Betul, sir.
So kamu kena tambah apa?
Radius of Earth.
Okay, good, very good. So you still have this small part. Tiga ni dia. Kurang pula saya. Okay. Ayo. So you have to add with the radius of the Earth to get your R. Okay, so R is basically equals to radius of the Earth plus dengan 40,000 times 10 to the power of 3. Ada yang tak faham tak this part? Okay, I assume semua faham lah. So it will be 6.4. Okay, good.
Saya nak tanya,
Yes?
macam mana kita nak tahu bila kena tambah R yang bumi tu, R besar?
Okay, bila dia kata sebab R yang kecil ni kan, dia sentiasa center to center. Dia mesti daripada center to center of the two objects sebab kita pakai point mass. So mass tu semua dekat tengah-tengah, ni kat tengah-tengah. And then most of the time, especially kat tutorial ni lah, dia kasih altitude. Altitude ni melambangkan jarak daripada surface dia ke tengah-tengah satellite. So dia tak consider this distance lah. So that's why kamu kena tambah dengan radius of the Earth. Kalau tak perlu tu masa dia kata jarak, kata yang contohnya dia kata communication satellite orbiting the Earth at a distance of from center to center 40,000 km. Pada kata center to center, you don't have to add up. Okay, biasanya dalam exam dengan dalam soalan tutorial ni kena tambah. Sebab apa? Dia kasih surface to surface. That's why saya cakap walaupun soalan dia simple, try to draw. So if you draw something like this, you can see clearly lah yang kamu kena tambah yang this part. Menjawab tak soalan kamu?
Boleh saya menjawab?
Okay, alright.
Thank you, sir.
Alright, it's a good question. So here, berapa dapat ni? Okay, lagi satu Pernah 1 tahun tu, saya tak tahu saya pernah cakap tak dengan kamu. Saya tanda 1 college. Sekejap, saya ambilkan juga. Negative 8.63, betul? Okay, try to check. Okay, sebab apa? Pernah 1 tahun tu, bila kami tanda satu college ni, dia punya jalan kira semua betul, cantik. Gantian betul, sini betul. Ni betul, ni betul. So dia dapat markah kat sini lah. Tapi bila jawapan akhir je salah, jawapan akhir je salah. Almost all the questions and dia happens dekat almost most of the student dekat daripada college tu. So kita orang rasa lah, bila dia belajar, student ni dia tengok pensyarah dia tekan apa, dia assume okay, it makes sense, semua make sense, and then dia terima apa yang pensyarah dia tekan. So dia tak tekan. So bila dalam exam dia tekan, dia tak letak kurungan. So kalau kamu tak training benda ni, benda basic je, tapi itulah. Kasi lupa letak kurungan dan soalan.
Itu sir.
Kan?
Dapat sama sir.
Dapat sama And lepas tu kalau dengan saya ni, memang kamu kena kira. Sebab apa? Sebab saya selalu salah tekan. So, kalau tak check, kebanyakannya tu memang salah. Coba hari tu lagi, salah, nanti kamu tengok balik, kamu pening. So, try check so that number one, kita boleh practice sama-sama. Number two, kalau saya salah, kamu boleh betulkan. Saya tekan kalkulator, saya tekan kabut sikit. So, biasalah tu. Okay, moving on to the next question. Ini ada soalan tak? So, negatif tadi biar je Okay, question number 11. Compute dia kata, ayat nak fancy. Compute the escape velocity of the earth. Okay, you have two formula. You can use V equals to square root of Gm over R. Sekejap saya check betul tak? 2Gm over R dengan 2Gr. Okay, dia pakai capital R bawah. Okay, kalau dulu chapter ni dia jadi bermasalah sebab formula tak diberi. Okay, so student selalu terlupa square root lah, terlupa letak 2 lah, kadang-kadang terlupa nak square, kadang terlupa nak cube. But now, sepatutnya tak ada masalah for you guys. Anyway, kalau kita ada case ni, kamu nak pakai formula mana? Ini ke ini? Kiri, kanan? Which one?
Kiri sir.
Kiri. Sebenarnya dua-dua boleh, kiri kanan boleh. So yang kiri ni, dia tak terhad kepada bumi lah. You can use it on the earth, kalau dekat Marikh ke apa ke, you simply have to substitute the mass of the Mars ataupun the radius of the Mars, mass of the moon, radius of the moon. Kalau dekat bumi, maybe you can use this simplified. Okay, you can try to calculate both and then compare the answer. So maybe saya cuba yang belakang tu kot pendek sikit. Baik, tak payah tanya Anyway, square root of 2 G ni adalah G 9.81. R here will be radius of the earth 6.4 times 10 to the power of 6. But remember, this one only valid for earth. So any object, when you try to escape the velocity, when you try to calculate the velocity of V escape, dia hanya ada satu value je sebenarnya. Kalau kamu perasan lah, tak kisahlah objek tu berat ke ringan ke apa, yang penting mass, velocity dia. Mass dia doesn't matter. Okay, anyway. The main reason is because you are doing this equation datang daripada conservation of energy. Conservation of energy ni kalau dipotong-potong M, hilang lah M dia. So here you get 11.21 times 10 to the power of 3. Unit dia apa? Okay, it's a velocity. So unit will be ms minus 1. So whenever you see the keyword like escape, straight away this one is escape velocity. Dua formula. Kalau dekat bumi, you can use the second one tu, and straight away you should get the answer. Senang sangat. Ada soalan?
Tak ada sir.
Okay. Kita move on lagi. Kamu nak rehat ke nak habiskan je? You guys need a break or not?
Saya okey je.
Okay, okay, maybe kita teruskan je lah. Rasa tak banyak pun ni. Maybe kita boleh habiskan terus. Okay, moving on to the next question, which is question number 12. Okay, a satellite is moving in circular orbit around the Earth at a speed of 5 times 10 to the power of 3. Calculate the satellite altitude over the Earth's surface and the period of the satellite. So first thing first, maybe you can try to draw the diagram. Dia kata ada satu satellite ni moving around the Earth. So this is your Earth and this is your satellite. Okay. Tak tahu map apa tu. Dia kata benda ni orbit around the Earth, satellite ni. Okay. They give you the speed. So ini speed apa? V lah kan? V escape ke bukan?
Bukan.
V bukan So ini tak ada kena-mengena dengan V escape tadi. It's two completely different things. So kalau kamu boleh bezakan which and which, so senang lah sebab formula yang ni, subtopik yang ni dia ada dua formula je, iaitu V equals to, kita ingat formula, square root of GM over R. Beza dia yang ni tak ada 2 tu. Lepas tu kamu ada lagi satu formula, period T equals to 2 pi square root of R cube over GM. Betul tak? Okay, betul. Okay, so the question gives you the velocity and they want you to find the altitude. Altitude tu boleh dapat daripada mana?
R, sir.
R. Okay, so altitude actually distance. Okay, kalau altitude jarak daripada mana ke mana?
Above Earth.
Okay, good. Daripada surface dia straight ke sini. Ini adalah altitude. Ada yang tak faham tak? You guys clear on this? Altitude tu melambangkan apa?
Faham.
Faham Okay, so kalau kamu kira and let's say you get the R tu actually represent this distance. Okay, so once kamu dapat R tu, basically you can minus or deduct with R of the Earth and you should get the answer. Okay, boleh faham tak idea dia? Kamu nak cari apa ni? So A,
Faham.
faham lembut je kamu ni. Faham. Boleh.
Faham sir, boleh sir.
Okay, GM over R. Okay. Saya petang-petang ni saya malas nak laju-laju. So kita buat slowly. Tapi bila saya buat slow, kamu jangan ngantuk pula. Kalau saya buat laju kan, benda tak faham. Okay, square root of 6.67 times 10 to the power of negative 11 multiply with, okay, mass ni mass apa kamu nak pakai? Mass satellite ke mass bumi?
Bumi.
Okay, kalau kamu confused, kamu tanya diri kamu, M ni M besar ke M kecil? Huruf besar, huruf kecil?
Besar.
Besar tulisan saya tu lebih kurangnya besar dan kecil, tapi sebenarnya dia adalah huruf besar. So kalau huruf besar, maksudnya dia adalah mass yang besar ataupun mass yang menarik benda tu, ataupun mass source of gravity, which is obviously yang Earth tu lah. So kamu boleh bayangkan lah, kalau dalam exam kamu confused, fikir balik macam tu. So this one will be 6 times 10 to the power of 24. You can calculate the R. So kalau saya dapat macam ni, saya buat manual tak, saya memang tak reti nak buat sekali tekan banyak kan. Tapi kamu boleh tekan banyak kot kalau kamu reti. Saya buat sikit-sikit, 5 / 10⁻³ square, lepas tu 1/2, lepas Lepas tu darab dengan 6.67 exponent negative 11, 6 exponent 24. Dapat A is 1.6 times 10 to the power of 7. Betul. Unit dia kilometer ke meter?
Jawapan saya berapa sir?
1.6 times 10 to the power of 7. Dia belum jawapan akhir lagi. Dia baru R.
Dapat sama sir.
Dapat sama Unit dia apa? Meter ke? Kilometer ke?
Meter.
Unit dia apa?
Meter.
Meter. Sebab apa? Sebab dia SI unit. Okay. Jangan confuse pula. Okay, this one is your R. The question want you to find the altitude. So you still have to use altitude. Okay. And based on the diagram, the altitude here is equivalent total distance R minus dengan RE. So it will be R minus RE, which is the radius of the Earth. Again, that number ada dekat depan tu. So this one kamu boleh dapat 1.6. Okay. 9.6 times 10 to the power of 6 meter. Okay, here you have to be careful a little bit. Katakanlah dia ada banyak perpuluhan, kan? And then kamu tulis satu tempat perpuluhan ataupun dua tempat perpuluhan over here. Bila kamu tekan calculator dekat sini, make sure kamu tekan apa kamu tulis lah, which is satu tempat perpuluhan atau dua tempat perpuluhan. Jangan kamu biarkan dia answer yang A and S tu kan. Yang tu jangan. Okay, sebab kalau lari, bila dia check lain jawapan dia, tolak langkah. Understand or not?
Yes sir.
Okay, so that one is for the A. For the B, they want to find the period. B is straightforward lah. T is equals to 2 pi square root of R cube over GM. Okay, jangan salah pakai R. Here the R will be center to center lah, bukannya altitude. So you use this one. Okay, 1.6 lah. To the power 7. Jangan lupa ada cube. 6.67 times 10 negative 11. Mass of the earth 6. Mass ni mass of the earth ke mass of the ni?
Oh, wait.
Sebab dia capital mass, capital M. Okay, buat sesama kalau tak buat nanti mungkin kamu akan mengantukkan. Okay, we 1.6 to the power of 7 to the power of 3 divided by 6.67, 6e negative to the power of positive 24 square root. Jangan lupa darab 2 pi tu. .01. Betul? Unit second. Dikatakanlah kamu tekan, kamu dapat nombor panjang-panjang tu kan, kamu tak tulis dalam prefix. Kalau siapa-siapa yang tak tahulah, kamu tekan ENG dekat calculator kamu tu, dia ditukar kepada prefix. Okay. So dia tak kisah pun dua-dua diterima. Kamu tak tulis panjang-panjang boleh, prefix pun boleh. Biasanya kita tulis dua decimal place lah. Any question?
Tak ada.
Tak
Ada sir.
Okay. So question 12 boleh buat. Maybe kita boleh buat satu lagi kot. Sebab saya rasa tutorial ni dia punya soalan sama je. 12, 13, 14 I think sama. Tadi kita buat berapa? 12 lah. Okay, so 13, 14. Kamu nak buat yang mana? Kita pilih satu je lah. 13 ke 14? Which one? Lagi satu tu kamu buat sendiri. Boleh? 14. Okay. Dia mesti ingat yang soalan last tu susah kan? Tapi tak kali ni yang last tu senang.
Let's say 13.
It's too late.
Besar. 14.
Senang je lah. Semua senang. Don't worry. Gurau je. Kenapa saya suka 14 ni? Sebab ini lebih menggambarkan soalan yang mungkin ditanya dalam exam. Sebab apa? Dia banyak pakai fancy word. Fancy word ni dia saja nak confusekan kamu. Okay, contohnya dia kata, determine the time and the speed. Okay, dia suruh cari masa dengan speed. Time ni sebenarnya soalan dia tak tepat. Dia more to period. For the International Space Station to orbit the Earth in circular low Earth orbit, which is typically about 400 km from the Earth's surface. Okay, so ISS ni dia saja letak supaya confusekan kamu. Ayat ni tak penting pun. It doesn't really matter pun dia ISS ke, apa type of satellite ke. And then circular low Earth orbit ni pun doesn't really matter. Dia just letak je untuk confusekan kamu. So basically, nothing important. Okay, so saya potong so that make much clearer. Okay, so dia kata 400 km from the Earth's surface. Okay, that's the important thing. So katakan saya nak lukis gambar macam biasa. Kita ada bumi. And then we have, this is the Earth. Then we have the satellite, which is orbiting around the Earth. Okay, buruk pula. Okay, dia kata nak cari speed dengan period kalau 400 km from the Earth's surface. Itu dia punya apa yang diberi tu? Jarak daripada mana ke mana?
R.
R ke surface?
Surface, altitude dia.
Okay, altitude. So maksudnya itu sebenarnya adalah dia punya ini. Altitude. 400, I change straight away to meter. So kalau kamu nak kira, kamu ada dua formula, which is V equals to square root of GM over R dengan T equals to 2 pi square root of R cube over betul ke formula ni? Lupa lah. Betul lah. Pertama saya confuse sikit. Dan saya nak copy this one. So I can put it over here. So that easier. Oh, kat bawah tu ada. Anyway. So, kalau kamu nak kira velocity, obviously dia suruh kira period. Okay, kita kira period. So kalau kamu nak kira period, you can use the T equals to 2 pi square root of R cube over GM. Okay, G tu constant lah, tak ada masalah. 6.67 times 10 negative 11. Okay, M tu nak pakai mass apa?
Gravity.
Mass of the earth kan? So 6 times 10 power of 24. So ni dia kasih satu mass, so tak ada masalah lah. Kadang-kadang dia saja dengki, dia kata mass of the satellite tu 100 kg. Dah student confused. Okay, anyway, the R here will be equals to apa? Nak kena tambah ke tak ya?
Tambah.
Okay, ni R dia, yes. So this will be RE, radius of the earth, campur 400 tu. So it will be 6.4 6 campur dengan 400 times 10 to the power of 3. Okay, jangan lupa ini ada cube kuasa 3. Cuba tekan calculator. So the only problems now, tekan calculator. And bila prefix ni, student selalu ada masalah. Mungkin saya pun tak tahu kenapa. Jangan lupa darab 2 pi tu. Okay, dapat tak yang atas tu?
Dapat, sir.
So to calculate the velocity, you only have one formula, gm over r. Again, mass adalah mass of the earth sebab capital M tu. The radius perlu tambah ke tak ini?
Perlu.
Perlu, okay, good. Tambah juga ya. So now you get 6.67 as 1 to 11 minus 6 times 24 divided by 6.4 tambah 400 as 1 to 3. Then take the square root. Alright. Okay. Ada soalan?
Tak ada.
Dapat sama?
Dapat, sir.
Okay. Okay, before kita berhenti, saya nak bincang sedikit pasal objective question. Sikit je, ada 5 soalan. Okay, for objective questions, macam anak saya nangis tu, kamu dengar?
Dengar.
Betul dengar eh? Kadang dia nangis tak ada sebab eh. Memang drama. So, saya dah tak risau sangat. Kalau awal dulu je.
Biasa, sir.
By the way, kamu dah ready ke kalau kena masuk? Kalau lah.
Tidak. Tak nak.
Tak nak?
Tak nak.
Bukan pilihan
Tak
kita lah.
nak.
Nanti
So
tiket
it depends on
mahal.
our phase, fasa berapa eh. So hopefully dia boleh at least sampai akhir semester ni lah. Tapi saya rasa Labuan dah masuk minggu yang awal bulan 10 tu. Kan? Okay, tak apa. Tu sampai masa kita fikir. For now, objective. Question number 1. Question number 1 ni saya skip dulu. Okay, I'm gonna skip because saya nak tunjuk kamu properly. And question number 2, which of the following graph correctly shows the relation between the gravitational force F between the two masses and their separation R? So kalau according to Newton laws of gravity, F is equals to G mass over R square. Kan? So kalau kamu ada graph F against R, so dia nak cari relation between F dengan R kan? So F, you can say that kalau kamu nak draw a straight line, it is directly proportional to the 1 over R square. So jawapan dia yang mana satu? A, B, C, D.
D.
Donkey. Okay. So make sure kamu faham, sebab mungkin dia tanya dekat UPS. Direct proportional indicates the straight line. Okay, and then kalau dengan syarat ni y axis, ni x axis. So y axis, x axis, the whole thing lah. Okay, when an object is thrown up, the force of gravity so dia kata dia baling objek. Force of gravity ke mana?
Opposite direction.
Okay, ke opposite direction. So in this case, the force of gravity will be in opposite direction. So yang B salah lah. Become zero at the highest point? No. That one is your velocity kan? Increase as it rises up? No. Just sebenarnya decrease. Okay, the answer is A. Question number 4. Force of gravitation is inversely related to inverse. So ni sama macam soalan tadi kan? Apa jawapan dia? Kalau atas, dia directly proportional. Kalau bawah, dia inverse. So inverse dengan square distance. Okay. Yang direct distance between ni dia tak letak square. Kalau square, yes, betul.
Okay, sir.
Okay, question number 5. What is the force responsible for maintaining a satellite's orbital motion around another body? Force apa yang kekalkan dia dalam bentuk circular motion tu? Ada normal, friction, centripetal, perpendicular.
C.
C, centripetal force. Okay, good, very good. So, object in circular motion, centripetal force. Okay, and then for question number 1, dia kata, if the distance between the two bodies is double, the force of attraction F between them will be, okay. What happen when the distance double? Okay, contohnya, initial you have this M1, M2, and the distance, let's say I put as R here is equals to R. Okay, jarak dia adalah R. Okay, after that, final, dia kata, what happen when the distance is double? Saya double check. Okay, the distance between the two bodies is now double. So maybe dia push a little bit further. Now dia punya R dah jadi berapa? Jadi R dia R. Kalau yang ni double, R dia jadi
2R.
okay, good, 2R. Okay, so initially my force will be using the equation, this equation lah. So semua equation, force equation kita pakai G M kecil M besar over R square kan. So kalau initial, maybe I put F je lah. Jadi G M besar over R square. Okay, this is the formula saya tulis. Okay, yang bawah tu saya dah substitute lah. Beza dia yang R kecil R besar je, saya masukkan nilai R je. Yang F baru, so I put the prime there. So G M M. Jadi berapa bawah ni? Per berapa ni?
2R
Okay, 2R. Jangan lupa dia ada square kan?
square.
Square tu the whole thing. Sebab yang square tu adalah R tu. R tu yang kita substitute sebagai 2R kat sini. So 2R lah macam tu. So I can factorize the 2R tu. Dia jadi 1 over 2 square G M M over R. Okay. And yang belakang ni sebenarnya equal to apa? This one sama dengan
F.
yes, dia sama exactly macam ni. Ya. So kita boleh substitute balik. So F oops, baru kita sama dengan 1/2 square which is 1 over 4 lah. And so this is how you relate between the new F and the old F. Okay, what happen when you double, triple ke apa tak kisahlah. So cara dia macam ni je. Senang sangat. You just compare and then you just substitute. So the answer would be 1/4F. So answer would be A. Okay, ada soalan?
Tak ada, sir.
Okay, ada soalan lain tak nak dibincangkan? Dalam tutorial. Kamu dah cuba itu buat kan? Ada soalan yang
Sir.
susah ke?
Tapi kan yang dalam kurungan tu dia GMM/R besar.
Okay.
Kalau force bukan R square.
Oh, R square. Yang ni pun R square, sorry. Saya lupa letak. Thank you.
Oh, okay.
Sebab yang dia square kan? Dia square dia dulu. Sorry, sorry. Right, good. Very good. Nice.